Moving on to the first question. State which of the pair of triangles in figure 6.34 are similar. Write the similarity criterion used by you for answering the question, and also write the pair of similar triangles in the symbolic form. Now moving on to the solution. Let us consider the two triangles in the first bit. Here, angle A in the first triangle is equal to angle P in the second triangle PQR, and also angle B is equal to angle Q, and angle C is equal to angle R. Now in these two triangles, according to AA similarity, as all three angles are equal, we can say triangle ABC is similar to triangle PQR. Now moving on to the solution for second bit of first problem. Here let us take the ratio of sides, that is consider AB by QR, that will be equal to 2 by 4, which is nothing but 1 by 2. And in the second case, let us consider BC by PR, which will be equal to 2.5 by 5, that is nothing but 1 by 2 again. And finally, let us consider the ratio of AC by PQ, which is nothing but 3 by 6, that is equal to half. So as all the ratio of sides, that is the ratio of corresponding sides, that is AB by QR is equal to BC by PR is equal to AC by PQ. So finally we can say that triangle ABC is similar to triangle A corresponds to Q, and B corresponds to R, and C corresponds to P. Finally, we can say that triangle ABC is similar to triangle QRP according to SSS similarity, as all sides correspondingly are in proportion. Now moving on to the solution for third bit. Let us consider the ratio of sides, that is MP by DE, which is equal to 2 by 4, that is 1 by 2. And also if we consider the ratio of sides, that is LP by DF, which is equal to 3 by 6, nothing but half. And here LM by EF is equal to 2.7 by 5. Here only two corresponding sides ratio is in proportion. So we can say that the given triangles are not similar. Now moving on to the solution for fourth bit. In triangle LMN and PQR, angle M is equal to angle Q is equal to 70 degrees, and MN by QR is equal to 2.5 by 10, which is nothing but 1 by 4. And here ML by PQ is equal to 5 by 6. Here angle is equal, but corresponding sides, none of them are in proportion. So we can say that the given triangles are not similar. Now moving on to the solution for fifth bit of first problem. Here angle A is equal to angle F is equal to 80 degrees and AB by DF is equal to 2.5 by 5, which is nothing but 1 by 2, and also BC by EF is equal to 3 by 6, which is 1 by 2. Therefore AB by DF is equal to BC by EF. Here the corresponding angles is equal and the two of the corresponding sides are in proportion. So by SAS similarity we can say that triangle ABC is similar to triangle FED. Now moving on to a solution for 6th bit. Here two angles of a triangle are given, that is angle D is equal to 70 degrees and angle E is equal to 80 degrees. Let us find angle F. We know that sum of angles in a triangle is 180 degrees. Here F will be equal to 180 minus 70 degrees plus 80 degrees, which is nothing but 30 degrees. So here we got F as 30 degrees. And in triangle PQR, we know that sum of angles is equal to 180 degrees. He has given the angles Q and R. So let us find angle P is equal to 180 degrees minus sum of two angles, that is 80 degrees plus 30 degrees, which is nothing but 70 degrees. So here we got angle P as 70 degrees. In these two triangles, angle D is equal to angle P and angle E is equal to angle Q and angle F is equal to angle R. Therefore, by AA similarity, we can say that triangle DEF is similar to triangle PQR. Moving on to a third question. Diagonals AC and BD of trapezium ABCD with AB parallel to DC intersect each other at the point O. Using the similarity criterion for two triangles, show that OA by OC is equal to OB by OD. Now moving on to solution. Let us consider a trapezium ABCD with AB is perpendicular to DC and BD and AC be the diagonals intersecting at O. Then we are required to prove that OA by OC is equal to OB by OD. Now in order to prove that, let us consider the two triangles OAB and OCD. In these two triangles, angle AOB will be equal to angle DOC since they are vertically opposite angles. Those will be equal about the common intersection point. And also, as AB is parallel to DC, angle C will be equal to angle A. As they are alternate interior angles with AB parallel to DC and CA as transversal. Now again, angle D will be equal to angle B since they are also alternate interior angles when AB is parallel to DC and DB as transversal. Here, according to AAA property, triangle AOB is similar to triangle COD. We know that when two triangles are similar, then their corresponding sides will be in proportion. So here we can say the corresponding sides, that is OA by OC, will be equal to OB by OD is equal to AB by CD. Here we need only the first two terms of proportionality, that is OA by OC is equal to OB by OD, which is the proof required for us. In figure 6.36, QR by QS is equal to QT by PR and angle 1 is equal to angle 2 show that triangle PQS is similar to triangle QTR. Now moving on to the solution. Let us note down the given information, that is QR by QS is equal to QT by PR and angle 1 is equal to angle 2. We are required to prove that triangle PQS is similar to triangle TQR. Now moving on to the procedure. If we consider in triangle PQR, angle 1 is equal to angle 2. We know that in triangle the sides opposite to equal angles will be equal. We can say PQ is equal to PR here. So let us replace the proportionality PR by PQ. Then we get QR by QS is equal to QT by PR. Replace it by PQ. Now if we consider this proportionality and compare it in triangle PQS and triangle TQR, now this can be written as, by cross multiplication, PQ by QS is equal to QT by QR. Now if we consider in triangle PQS and triangle QTR, PQ by QS is equal to QT by QR. So here two of the corresponding sides are in proportion, and also angle SQP is equal to angle RQT, which is a common angle in both the triangles. Angle SQP is equal to angle TQR, which is common angle in both the triangles. So finally, therefore, by SAS similarity we can say that triangle PQS is similar to triangle TQR. Moving on to fifth question. S and T are points on sides PR and QR of triangle PQR such that angle P is equal to angle RTS. Show that triangle RPQ is similar to triangle RTS. Now moving on to solution. He says that there is a triangle PQR in which S is a point on PR, let it be here somewhere, and T is a point on QR. Now he says that angle P, which is nothing but angle QPR, is equal to angle RTS. So he has given that angle P is equal to angle RTS. Here angle P is nothing but angle QPR is equal to angle RTS. Now he asked us to prove the similarity between triangle RPQ and triangle RTS. So let us consider them. In these both triangles, angle QPR is equal to angle RTS, it is given. And in these both the triangles, angle PRQ is equal to angle TRS, since it is a common angle for both the triangles. Angle QRP is equal to angle SRT, since it is a common angle. So now by angle similarity, we can say triangle RPQ is similar to triangle RTS. This is what the required proof for us. Moving on to the sixth question. In figure 6.37, if triangle ABE is congruent to triangle ACD, show that triangle ADE is similar to triangle ABC. Now moving on to solution. He has given that triangle ABE is congruent to triangle ACD. We know that when two triangles are congruent, then their corresponding sides will be equal. So here AB is equal to AC and the corresponding sides, that is BE, is also equal to CD, and AE will be equal to AD. Now we are required to prove that triangle ADE is similar to triangle ABC. So let us consider in triangle ADE and triangle ABC, that is ADE is over here and ABC is a larger triangle. In this, angle DAE will be equal to angle BAC, that is this angle, which is a common angle for both the triangles. Now here let us consider the two equations, that is AB is equal to AC and AE is equal to AD. Now AE is equal to AD can be also written as AD is equal to AE, which implies, let us divide both the equations, then we get AB by AD is equal to AC by AE. So here if we observe clearly, the corresponding sides, that is AB in triangle ABC by AD in triangle ADE is equal to AC in triangle ABC by AE in triangle ADE. Therefore, here two corresponding sides in proportion and one of the angle is equal. So therefore by SAS similarity, we can say that triangle ADE is similar to triangle ABC.